Hello everyone, this is Logic Coding. Today we are going to look at a very classical example, which is count the number of islands. So the input, we're given a 2D binary grid. So the grid only have its chars and only have 0 and 1s. 0 representing it's a water, 1 represent it's a land, and we want to return the number of islands. So the definition of islands is once. So all the connected ones are only one island, and this connectivity can be horizontal or vertical. And we can assume all four edges of the grid are surrounded by water. For example, let's go through the first example. The first example, we have ones, and we only have one island. The second example, we would have 3 islands, since the first 4 will become the first island, and this one is surrounded by water. It's the second island, and the last island is those 2 ones. So we can treat this as an undirected graph, where we want to count the number of connected components. So there, we can apply both DFS and BFS to do this. For this problem, I'm more comfortable with a depth first search method. The way is we do a linear scan of the grid, and if we meet once, then we do a DFS and we count plus plus, and at the end I can just return count. The main logic will fall behind inside this DFS. So for each DFS, I and j, so I need to mark the grid as visited, and then I need to do DFS for its 4 neighbors. And till the end, the number of DFS, which means the number of root node, will be the number of islands. So the time complexity would be OMN, where M would be the number of rows, N would be the number of columns. The space, it depends on how many recursion stack we have to call DFS. In the worst scenario, it's also going to be OMN if all the grid are ones. So within that, let's code it up. So let's first get our row number. And I will define a variable called count to count the number of islands. Then we do our linear scan of the grid. I is smaller than rows, I plus plus. J smaller than columns, J plus plus. When should we, what trigger this DFS is when the grid I and j actually equals to 1. And then we perform DFS in this grid. Let's put grid here. And we do count plus plus. Now let's define this DFS function. I'm not going to return anything within this DFS. So the input will be the grid and where it is and int j. So as always, as a recursion, let's consider the end condition, where we just need to return. So the end condition comes from either I and j are out of boundary, or grid ij does not equal to 1. So let's first still take columns number and row number. If I is smaller than 0, or I is greater or equal than rows, or j is smaller than 0, or j is greater columns, or my I and j does not equals to 1, I'll just return. Otherwise, we can do a DFS. We first mark it. We can make it equal to 2, or we can make it equal to 0. And then we just do perform recursively call this DFS for its 4 neighbors. So to walk through this example, so this is going to be our main code. So for example, when we call first, when we are here, it's equal to 1, it triggers this DFS, and ij would be 0, 0. So this will be marked as 2. The second will mark this 2 as 2, and then mark this one, this one, this one as 2. And we just keep exploring until all its neighbors are 0 or out of bounds, and we return the count number. Let's try run the code. Looks good. Submit it. Perfect. That's it for this question. It's a pretty classical application of DFS. I would say 2 very important things is to know when the DFS will be triggered, and also know the end condition and mark the visited node. Sometimes we need to create an extra visited Boolean value to present whether we have visited the islands, but the framework and logic is pretty much the same. Cool.